We will look at the derivation of Kp. So Kp is equal to Kc RT change in number of moles. So I want us to look at where this equation is coming from. So let us consider we have this example, equation. Let's say we have A plus B forms C and D. So let's say we have that equation, and then the coefficient of A, let's say A, the coefficient of B is small p, the coefficient of C is C, and like that. So Kc, the expression of Kp is equal to the pressure of C times the pressure of D times the pressure of D. So the C as a coefficient of C, so that we say power C there, and then D power D all over the pressure of A power A times the pressure of B then raised to power P. So this is the expression of Kb. Kb is equal to the pressure of C raised to the coefficient times the pressure of D raised to the coefficient all over the pressure of A raised to the coefficient times the pressure of B raised to the coefficient. So that is the expression of Kc. Let us consider the ideal gas equation. Ideal gas equation, BV is equal to nRT. So this is the ideal gas equation. So P alone will P, the pressure will be equals to nRT all over V. So that means we can separate N over V and RT. So we can have P is equals to N all over V RT. So N over V means what? N over V, number of moles divided by volume, will give us molarity or the concentration. So we can replace N over V with molarity. So that will be P is equal to molarity RT. So that is what we will have for pressure. Then if, for instance, we want to have the pressure of C will be equals to PC, that is pressure of C is equal to molarity, that is the concentration of C, molarity is just simply means the concentration. So we can have now BC, that is pressure of C is equal to the concentration of C R multiplied by RT. And then for D, we'll have the PD is equal to the concentration of D RT. And for A, we have PA is equals to the concentration of A RT. And for B, the pressure of B is equal to the concentration of B RT. So from there now, we can replace where we have PC with concentration of C RT, and for BD concentration of D RT, and the PA we can replace with concentration of A, RT, and for P, we can have concentration of B, RT. So let's simply now replace what we have in the equation. So we'll have for PC, so Kp is equals to, for PC we have got concentration of C, RT. So C, concentration of C, RT. Then all of that to power C. To power C, and then times the concentration of times D, which is, we have got concentration of D, RT. Concentration of D, RT. Then all of that power to D, all over. For PA, we have got the concentration of A, RT, the concentration of A, RT, all of that power to A, and then the concentration of B, RT. Then the whole of that power to B. So that is what we have there. We have now replaced our PC, the concentration of, the pressure of B, the pressure of D, A and B, and we have got this equation. So this simply means C, the power of C is for both C and RT, and the power of D is for both for this D and RT. So we can separate the two. So let us say Kp is equals to the concentration of C, power to C, times RT, power to C. We have only separated what is in the bracket, and both of them they have a power of C. And then let's also separate this one. We'll have times the power of D, the concentration of D, power to D, and then the concentration of RT, power to D, all over. Let's also do the same for this one. So we'll have, we have got, here we have A, not C. And then, so the concentration of A raised to small a, RT raised to A times the concentration of B raised to P, and then RT raised to P. This equation is the same as this, but we have only separated the two. So from there, we will now replace, or let's consider a Kc in this equation. If we have this equation, A plus B forming C and D, the Kc is equal to, the Kc will be equal to the concentration of C times the concentration of D power to the coefficient, all over the product, that is the concentration of A, all over the concentration of B. So let us write that expression so that we will have an easy understanding. Kc is equals to the concentration of C raised to C times the concentration of D raised to D all over the concentration of A raised to A times the concentration of B raised to B. So this is Kc. So whatever we have here, we can now replace with Kc, because here we have got concentration of C raised to C and concentration of D raised to D. Here we have got concentration of A raised to A and the concentration of B raised to B, and that simply gives us Kc. So let us rearrange this one. We will have Kp is equals to the concentration of C raised to C times the concentration of D raised to D, then RT multiplied by RT raised to C, and then we have got RT raised to D all over. Then let's also rearrange this one. We'll have the concentration of A raised to A times the concentration of B raised to B, then RT raised to A times RT raised to B. So the whole of this is Kc, because Kc is the concentration of C raised to C times the concentration of D raised to D over the concentration of A raised to A times the concentration of B raised to B. So the whole of this we can replace with Kc. So we can have, so Kp is equals to, Kp is equal to, since we have replaced the whole of this one with Kc, we will have Kc, and then we have got RT square, RT power C, RT power D, and then RT power A, RT power P. So we have Kp is equals to Kc, RT power to C, and then RT power to D all over RT power to A, then RT power to B. I think we have to go up to that point. Okay, and from there, Kp will be equals to, so let's now, the base here is the same, so the indices will have C plus D if the power is the same, and here we have multiplication, so we'll add the power. So here we have got Kc, Kb is equals to Kc RT, then C plus D, and this one RT, we add the two powers, A plus B. Okay, again, the base is still the same. So indices, so this is division, so we subtract the two indices there, or the power. So according to the rule of indices, we subtract the power. So Kp is equals to Kc, then RT, and then C plus D minus A plus B. So this simply means we have only subtracted the power, the two powers. And then, so this will give us the change in number of moles. So we can have now all of these change in number of moles, that is change in N, because the power was the mole ratio. So we can have now the change in So this will give us change in N. So Kp is equal to Kc RT. All of this we have replaced with change in N, since it is a subtraction of the power, and that is concerning the number of moles. So that is how now we have arrived our equation, which is Kp is equal to Kc RT change in N, which we have got here. And then that is how Kb is derived. Thank you for watching the video. Please